All right, let's look at 9G, which is bivariate data and scatterplots. Now, for those of you who are thinking about doing further next year, this is something that is involved in further. So this will definitely help you out for then if you manage to do a good job and learn it reasonably well now. So let me just talk about what each of these things actually are. So bivariate data, it's when we're given information like that's about two variables. Now you might see that I've underlined the word two and also bi in bivariate. It's because we're talking about data with two variables. Okay. Now, as it says here, often the two variables are related. Sometimes they're not, but most of the time they are. So, for example, um, height and weight would be related. So someone's weight probably depends on how tall they are. And again, if we're doing some sort of journey, the time that it takes to do the time that it takes to do that journey probably depends on how far you have to travel as part of that journey. Okay, so hopefully we can see that these variables are related. Now, the second part of the title, scatterplots, which I'm going to show you soon. So a scatterplot's a graph that shows the two variables and the data that relates to both of them. So a scatterplot has a whole heap of dots. Each dot represents each piece of data that you've been given. So what we're going to do here, now this example, it sort of has a few parts. We have an A, B, and C. I just want to focus on A for now, and then we'll come back to B and C in a second. So we'll break it down a little bit. Now, whenever you're asked to draw a scatter plot, which we are just here, you're given pieces of information. So you've been given a table here that shows for a few different people their height compared to their weight. So this would be the first person, the next person, the next person, etc. So we've got 1, 2, 3, 4, 5, 6, 7 people, and their information about height and weight. So what I'm going to do is put dots on this graph here that relate to this stuff here. So the first person is 165 centimeters. So I've got height on my x-axis here and weight on my y-axis. So height is 165 centimeters, which would be about here, and their weight was 70, which is just here. So if we line those ones up, there's our first dot. Okay, so let's go to the next one. This person's 190 centimeters and they're 92 kilos. So 190 and then 92 would be around about here. Be a lot easier if we had graph paper, but I'm going to do the best I can. The next one, 171 centimeters, about here, and 85 kilos. So something like that. I'm trying to be as accurate as I can. Next one, 161 centimeters and 58 kilos. So 161 and 58 might be like around about here. Next one, 157, about here, and 63, something like that. Next one, 195 centimeters and 100 kilos. So it'd be something like that. And then the last one, 181 centimeters, about here, and 72 kilos. So around about that. So done. We've made our scatter plot using that data that we've been given. Now, what you might notice, let me just move up here for a sec, is that do you see how there's sort of a pattern here? It looks like that, like we've got a bit of a line. Now it's not absolutely perfect, but there does seem to be a pattern, doesn't there? So it seems that like the taller you are, the more you weigh. And you're often going to see these patterns. Now, a word that's really common, or that's key really, is correlation. So you might be asked about correlation strength and also the correlation direction as well. So let's just focus on strength first. Now, correlation is strong if all the dots are really close together like that. Okay, so all the pieces of information that you've been given, they really follow a certain trend. So if they're close together like that, we would say the correlation is strong. Now, they're not always strong. Sometimes they can be weak as well. So with this example here, can we see how they're more spread out, but they still seem to kind of follow that line that's going upwards? So they can be strong, they can be weak, but they can also have no correlation, where the dots are just completely random. So if I look at this one here, I can't really tell any sort of trend that's happening. They seem to just be all over the place. Okay, so let's move back up here because the second question was describe the correlation between the height and weight. Oh no, we'll go to C, sorry. Describe the correlation between height and weight as strong or weak. If I look at this, it's pretty easy to see the pattern, isn't it? It's a reasonably straight line. So I would say that the correlation is strong. Done. Now we'll do B, but I'm going to show you about B here. Now, correlation direction, it's just whether it's sloping up or down. So it's just like a linear equation. If you've got a positive gradient, it means your slope's going up, therefore positive direction. But if you've got a negative gradient, your slope's going down, therefore a negative direction. Okay, so if we look up at this one here, it looks like it's sloping upwards, doesn't it? So if we were talking about gradient, it would have a positive gradient. So therefore we can say the direction of this one is positive. And there we go. Hopefully that helps for your questions.